Hey guys, welcome to the third session of the Python for Revit course. It took me a little bit while to actually publish and create this new session because I was going through an online course on databases. I find a lot of the concepts in dealing and understanding databases similar with Revit as well, and it helps tremendously with understanding how Revit behaves in certain ways when we're dealing with making changes data to it and like reading data and updating data and stuff like that. So in this, I want to dedicate just this session as a sort of like a quick session as an introductory to relational databases. I really think these concepts is going to help us understand Revit better. So let's talk about databases a little bit more and specifically relational databases. Um, Relational databases are a very popular category of databases in the world. Um, they are organized based on tables that have relationships defined between them. So let's talk about an example. Let's talk about a company. Let's assume that I own a company which sells only one product, which is an iPhone. And then I want to record these orders that are received with the information about each order in a database. So basically, I create a database. I create a table in it that is, it's just for the orders. And what I can do is that I can put an order number, the product, the amount, the total, the amount that I'm selling, basically the count, the unit count, and then the total would be a calculated value based on the unit price and the unit count. As far as the information about the customer goes, I can put this information right here, and I can type the name, last name, credit card, and zip code. But the problem is that if this customer ever places another order, I need to duplicate that information somewhere else on a different line. And that's a very bad idea. So what we do is that we create a completely different table and we call it customers. And we record all the customer information in this and we give each one of them an ID that uniquely identifies that customer. And then we come back to the orders table and create a customer ID table and we put the ID of that customer that placed that order. And that means this is nicely done and we're not duplicating any information and stuff like that. The only thing that's being duplicated is the customer ID, which is completely understandable because you need to have a way of telling which customer placed that order. And the information about the customer is only placed one time in the whole database. This connecting the customer ID column from this to the customer ID column in this table, that's a relationship. And that's why they're called relational databases. This is a one-to-many relationship, meaning that one customer can place many orders. Um, this column, this basically key, we're going to call it from now on, is called a primary key because it's a number that uniquely identifies each one of these entries. You're going to have the same thing over here too for the order number. That's going to be the primary key because it uniquely identifies that single order. Some of the databases can create different, automatic primary keys. Like you can have a unique ID here that is generated by the database management system. So you're going to have like unique numbers in here. You don't have to necessarily use any of your actual data as your primary key, but generally that's how things are done in the relational database world. So what I'm not trying to imply that this is how Revit works or this is how Revit saves its file format. That's obviously a proprietary format that we don't know how does it work. But looking at Revit and dealing with it with the understanding of the concepts of a relational database helps me at least understand why Revit acts in a certain way. And as I was talking more about the databases, I can explain. You can see the how it actually helps. So anyway, excuse me. There are there are two really powerful acronyms that are related to databases. One is CRUD. So in dealing with the database, we want to be able to create, we want to be able to read, we want to be able to update, and we want to be able to delete information from this database. This is extremely important for us to do. I like this so much that I actually started putting this on this session's titles on the YouTube screen. What's it called, the screenshot of the thumbnail of the video, so you can see what subjects I'm talking about in that specific video. Like in the next video, I'm going to talk about how to update information and how to delete entries from a Revit database. This helps simplify things a lot. Now, let's talk about making changes to a database. So I can talk about that ACID acronym. Imagine I have a database. Excuse me. Imagine I'm a bank and I have a database of one account that two customers share. The total amount in that account is $5,000. Now, imagine Lisa and Bill both at the same time want to deduct $1,000 from the shared account. So Lisa comes in, reads the value of that, deducts $1,000 from it. I'm going to put all the new values in here so we can talk about both of them at the same time. So writes that value back to the so deducts $1,000 from that, adds it to her own account, and deduct it from that and write the value back in the original cell. But imagine Bill is doing the same thing at the same time. So he's also reading $5,000, deducting $1,000 from it, writing back $4,000, and adding the deducted value to his own account. What we end up having is losing $1,000 from the bank. Obviously, Lisa and Bill are going to be very happy because they both, got $1,000, but only lost $1,000. But this is not going to be obviously okay because this is not a valid state in a database. The database only had $5,095 in it, and now you have $6,095 in it, which that doesn't make sense. To avoid this, we create this concept which is called a transaction. So every time you want to make a change in a database, you have to open a transaction. You have to tell the database, okay, I am starting a transaction. I'm doing all these actions of reading and updating these values, and then when I'm done, I'm going to close the transaction. So the database understands that, okay, this whole bunch of actions that it did is one transaction. Now I'm going to do all that, and the database, I'm going to check that the database state is valid. What it means that when Lisa pulls that information, starts a transaction to pull $1,000 from the shared account and put it in her account, a transaction is started. So Bill has to wait for Lisa's transaction to be completed. And that means when later Bill starting a new transaction, instead of reading $5,000, he's going to be reading $4,000 because that's the value that at the end of the Lisa's transaction were written to the database back, and database state is valid. So what's very important about transactions is that they have to be ACID. They have to be atomic, and I explain each one of them. They have to be consistent. They have to be isolated, and they have to be durable. Atomic means that a transaction might contain multiple different steps. All those steps might happen at the same time or not happen at all. You can have deducting $1,000 from this and not adding it to their account and losing that $1,000. That cannot happen. So either all these actions have to happen inside a transaction, or the transaction they should not happen at all. Consistency means that a transaction has to take the database from one valid state, like from $5,095, to another valid state, which is also $5,095. This is consistency. Isolated means that basically, let's talk about locking. So the data has to be locked. So for example, when Lisa starts the transaction, she locks this information that's here. So Bill really can't read that, and he has to wait until Lisa's transaction is unlocked, completed, so he can read it. That's what isolated means. And then durable means that when Lisa or Bill both completed the transactions, and if they completed the transactions and just server crashed right at that moment, and then server restarted and loaded the database again, the information shouldn't revert back to the previous because the transaction was complete. And that means that the database changes that are made to the database needs to be durable. So when the database management system is closing a transaction, it has to basically verify that all the information has been written to the database, everything is okay. So if it crashed and loaded next time, it can maintain that information. That's closing a transaction. Otherwise, it has to tell the program that, oh, the transaction wasn't closed. So knowing all this, we want to talk about a little about Revit's transactions. This is exactly how we deal with Revit document, looking at it as a database. Let's say you have a bunch of elements in a database, in a Revit model. Let's say you've got a wall, you've got a window, you've got another wall, you've got a door, and each one of them has a unique ID that identifies that single object. And we're going to see this over time, over this course, and how we deal with objects in Revit. So if I want to delete that wall, let's assume that this window is hosted on that wall. If I'm going to delete that wall, this window will need to be deleted. So this change that I need to make to the database, I have to do it inside a transaction, because we want to make sure that when we are deleting this, so we want to make sure that when I'm deleting this, nobody else is moving that window or making any changes to this wall. And that's why when we start a transaction in Revit, nothing else can touch the database. That our program or our script that opens that transaction is the only thing changing the model at that moment. We do our changes, we basically tell Revit these are the changes that we want to make, and then we close or commit the transaction. When we commit the transaction, Revit actually goes in and starts doing all those stuff, and then it verifies that everything is fine. It returns some information back to us related to the transaction, and then let us know if the transaction was successful or wasn't successful. This concept is obviously expandable, so you can have like groups of transactions. You can have multiple different little transactions inside of bigger transactions, and we'll get to that in the future. Just as it's sort of like a pseudocode, I want to show you where the transaction is. So I'm going to go to Revit API Docs, which is a website created by Guy, my friend, that is basically lists the SDK documentation for all the different Revit versions from 2015 to 2018 that's current. I'm going to search for transaction, and firstly the transaction class. So I'm going to go inside that, and I'm going to look at there are examples to it. This is written in C#, so I'm not going to use that, not to confuse you, vb.net. I'm going to go to the members of the transaction, and I'm going to look at that. So see, there are two methods on this one that we care about. One is start, that starts the transaction, and the other one is commit, that commits all changes made to the model during the transaction. That's exactly what we talked about. So we start a transaction, make some changes, and then commit the transaction. And this is how basically it works. If you look at under the constructors section, it basically tells you the two different ways that you can create a transaction object. So I'm gonna show it to you very quickly here. I'm gonna actually keep that window open just in case. So we want to use from the Revit database, from Autodesk Revit DB import transaction. And the way I know this is because that's what it says here. Autodesk Revit DB, that's where that object lives. So I'm going to import the transaction, and I'm going to say T equals transaction. So I'm creating a transaction object and assigning it to T. And I need my document also. We can grab this from another video, or I can go actually, let's see, I think I have it open somewhere. Yeah, okay. I described this in a previous video, how you can grab the document object, the current document from Revit Active UI document and document. This is the document that's open and visible in Revit session right now. And this is the document that we want to make the transaction in. So we start that. This is one way of doing it, or you can give it also a name, like deleting all walls. All walls. Which is going to be a bad transaction, I guess. And then what you do, the first thing that you do after this is to start your transaction. I mean, obviously, they don't really have to happen right after each other. They're two different statements. But between these two, before starting a transaction, you can't start making changes to Revit model. You have to start the transaction, and this here is where all your transactions, all your actions, or your create, update, or delete actions occur here. This is where you do everything, right? You make changes to the model. And then once you're done, you call commit. You can check for different, states in your script and make changes to it and stuff like that, and then decide if you want to commit the transaction or not. There are a couple of other methods on this that we're going to talk about them in future. One of them is rollback, that you're basically telling Revit, basically telling Revit that I don't want to commit the transaction, just roll back everything. Just forget about everything, cancel the transaction. This is basically canceling your transactions. So this transaction object has more methods to deal with transactions, just other than start and commit. But this is what we're going to talk about in this session. That's what we do really. We create the start transaction, make all our changes, and then commit the transaction. And then right after this, the transaction object will include the result of that transaction in it. So we can ask it to get status of the transaction. So you can say result equals t.getStatus, and it would return, sorry, I just moved to a different window, and it would return a value to us. If we go under this and look at that method, it would return an object, an enumeration object of type transaction status. And if you go take a look at that, there are different statuses for a transaction. It is either started, rolled back, committed, pending, error occurred, or proceed, or initialized. They're different things. So you can, after that, you can check if the transaction has been committed, meaning that simply committed, ending an empty transaction, flushed all, and undo is disabled. So that means that if the res equals transaction status dot committed, means that okay, the transaction has been committed and it was successful. You don't really have to check for this. You only check for this if you care about this. But basically, if you commit and no error had occurred, then everything is fine. Then the change has been done. The objects that you wanted to delete has been deleted and everything else. So I think I talked about most of the stuff that are really important in terms of dealing with databases and how we're going to look at Revit as a database. The only other last thing that I want to mention is that opening a transaction and making changes inside a transaction being the only thing that happened at the time, this is really the reason why Revit can't have two tools or two add-ons or two commands running at the same time. That's why when you run a command like this, for example, a tool like this, you can't really access anything else inside Revit's environment, because generally, by default, this thread is the only one that's active right now, and that's the only one that's allowed to make changes to the database. That's why generally you can't have multiple things running at the same time. Another quick thing that I want to talk about is that sometimes you have calculated values in your parameters. For example, when Revit stores the information for the wall, it doesn't necessarily might not store the geometry information. It might say, what's the thickness of that wall, what's the height of it, what's the starting point, and what's the ending point. And when it's actually reading the file and loading your model, it's actually generating that 3D geometry of that wall on the fly. So a lot of the information that we kind of like naturally expect to be in the database might not really be in the database. They are calculated parameters. So when Revit is loading, it actually computes and calculates the geometries for these and creates those. And I'll get to this in the future when in the next session when we talk about in a little bit more detail about reading the information and finding objects in Revit. There's certain information that Revit keeps it in memory. But there's certain other information about objects that it creates only when it's accessed, because creating all this takes memory and takes computing power and stuff like that, and make load time a little bit harder to deal with. So that's why for just sake of management, it doesn't calculate certain information until it's absolutely necessary. Imagine it like, for example, in this in the initial example that I had, imagine that the total value is not calculated unless somebody reads the value of this. So imagine the database management system doesn't really calculate any of these unless when somebody says, okay, what's the total for that? And it goes and figures out what's the value and then and then return that value to them. That's exactly what kind of Revit does. It retains this information in the database about a wall, for example, just the basic information where it starts, where what the construction is, what the structure is, what's the height of it, and stuff like that, and then generates the geometry and the rest of information on the fly when it's required. I'm going to close this session based on this, and in the next session, we're going to talk about how to update some information on some Revit objects and delete a bunch of objects, and generally talk about transactions and how we can open a transaction, close a transaction, and see it in action really.